Greetings, this is Ward Harriman, AE6TY. Those of you who have viewed my video about the new SimNEC display got a peek at the enhanced spreadsheet built into SimNEC. While there was a peek there, it was only a peek, and this video explains the spreadsheet in detail. So let's get started. So here I have a clean design. Let's bring up the example that showed us the peak. This is available in the standard distribution of 2.1, and so you can load it in and follow along if you like. I'm going to load the circuit description. Now I've been here before, but I'm going to walk you through it. Examples, network, the 5-element Yagi down here. Here was the spreadsheet that we got the peek to. And we'll bring up the SimNEC display. Now, we won't be using the SimNEC display much here, but it's nice to have it on the screen. As one can clearly see, this is a 5-element Yagi. There are many parameters to this Yagi. The length and position of each element, and there are 5 elements. And additionally, I want to be able to run the optimizer on it, so the initial position and length of each element is needed. All in all, that's 20 numbers, and I need the height. Don't forget the height. So 21 numbers. 21 numbers would be way too much to fit in here and have it be usable at all. So instead, we're going to use the spreadsheet. The SimNEC spreadsheet cells can be accessed using the traditional way. For example, in the rows block, to get the height, I could say B8. However, accessing cells in the spreadsheet in this way is cumbersome and prone to error. As a result, SimNEC Spreadsheet allows the user to enter labels for cells. SimNEC labels can be used to address specific cells or groups of cells. A typical single cell label is like that shown for the height right here. As can be seen, this type of label has 2 colons. If the 2 colons come at the end of the label, then the cell being accessed is on the right. If the 2 colons are at the beginning of the label, the cell being accessed would be to the left. So let's play with this a little bit. Let's add a daemon block. And inside that daemon block, let's access something inside the spreadsheet. So we could say height is equal to the spreadsheet H cell. And we can see that it's replicated. And if I change this number, it changes here, and likewise, I can set it back. Now let's add a new single cell label. Note that the syntax is a little bit cumbersome, and it starts with a equal quote and ends with another quote. So here I'm going to click on this. I'm going to say equal quote, and I'm going to make the label go to the left here, and I'm going to say this is foo, my favorite variable name. And I can set it to be a value. Now let's see if we can assign foo from the daemon block. So I'm going to say in fact, I can say it's foo, which makes a variable here, and as I change it here, it changes over here. So we can see that we can access the spreadsheet from circuit elements down here, and we can assign elements inside the spreadsheet from circuit elements down here. The second type of label allowed in the spreadsheet is a row or column label, and in these types of labels there is a single colon. For example, up here the ref colon says that reference, or reflector in this case, is either a row or a column. In this case, it's a row, and we've put it here on the left. And likewise, these are column labels, and so we can access a row and column simply down here. So we can say length is equal to the spreadsheet reflector length. And we can see that the reflector length is down here. One can actually examine the contents in the spreadsheet inside the daemon block. And I can print out all of the cells by simply saying print line the entire spreadsheet. This is a big thing because it's listing all of the cells. And interestingly, over here on the right, you can see the reflector, you can see the director. And so this lists everything, but it's probably too much to bother with. If you'd like to see just one of these rows, you can tell it to print line just the reflector. And here we can see all the information that you can set or get from the spreadsheet concerning the reflector. Now, care should be taken when setting up these labels for rows and columns. Having more than one row or column label in a row or a column is not supported, and SimNEC is not very forthcoming about what is wrong. Further, there is no way to move one cell's contents to another. You have to retype everything. It is best to have a solid plan before getting started. Having seen how to set up the spreadsheet, let's turn to how one might use it. And let's look inside the roost block. So we can get rid of this and get rid of this little bit of trash. And let's look inside the roost block. Here are the contents of the roost block. And let's move things a little bit because I'd like it to be all visible. Sorry for the distraction. All right, so there are 5 wires. And here, each of the wires is described using the endpoints. Now, this looks like a lot of typing, but in reality, it wasn't very much. That's because I specified this point with a piece of text, and then I copied this point to over here, and all I needed to do was get rid of the minus sign. And then I copied this wire multiple times, and all I had to change was the name here in the middle. Notice that there is one next source right here. I had to add it in and rewire it to get it connected to those points. Looking over here at the text dialog, here at the top we see the usual neck meters, and we tell the body graphic to be the antenna, which is why you see those wires there. I could add other notations, I just haven't done it here. And I have a few buttons, one which I call initialization, one is to do the various kinds of optimizing, and I'm going to skip over the optimize code. And down here at the bottom, the most interesting thing is what's called do initialization, and you can see that I copy these values over to here. So just for fun, let's do an optimization. I'm going to use Nelder Mead here before I get started. Let's look over here on the right. I got 14 dB going forward, and I got 7 dB coming to this backward lobe. Let's do an optimization for this frequency. So I always do an init. That beeping is Nelder Mead running. Sometimes this can take a while. And this gave me an increase in forward gain of about half a dB. But look at the backward gain. The backward gain is off the charts. And that's because this lobe right here is not at the same elevation as this. And if we We move this around a little bit. We'll see if we can get a view. Looking down that point, you'll see it's got basically a complete null here in the back. So you can use the viewpoint to look for this node. That's saying it's 80 dB down. I'd be pretty happy with that. While we're here, I'm compelled to show a few other features of SimNEC. For example, we can sweep the frequency and look at the SWR, which we're doing right here. That's kind of a long thing. Let's set the sweep to be 100 points. And we can use SimNEC to play with the hairpin inductor that's often put here. So let's put an inductor here because there usually is one in a Yagi. And you can see it substantially improved our SWR. Let's limit the range a little bit. And we can play with this a little bit. We can also plot things. I'm going to plot from the antenna the field, the max field point, and let's do a find. I don't care about power. And here is the maximum forward gain plotted along frequency. Okay, let's sum some things up. In this video, we introduced the SimNEC Spreadsheet. We explored the use of labels in the spreadsheet so that accessing the contents was made more intuitive and less prone to error. We showed how the contents of the spreadsheet can be examined or modified by circuit elements such as the roots or daemon blocks. A good example of this is when we ran the optimizer, it changed all these values. We then examined the roots block used to describe the 5-element Yagi. We saw how the wires could be described using SS cell values. Succumbing to temptation, we ran the optimizer, and we saw improvement at the design frequency. Further temptation had us plot the max gain across frequencies and even add the hairpin inductor often used in Yagi antennas. I hope you found this video instructive and perhaps even a little bit inspiring. The use of the spreadsheet greatly expands the utility of SimNEC, especially when applied to larger antennas. This is Ward Harriman, AE6TY. Thanks for watching.